Hey folks, here we go. This is our lecture for Design 330. It's Thursday, March 18th, and we're in our Google Meet. Today, we're going to pick up on just going a little bit more into work orders and milling program. I've pretty much covered what goes in your submittal for right now, but these will be extra things that put you above and beyond the minimum, and they will be useful to you next week as you finalize this and finish up this whole unit on manufacturing and design of the piston pump. So, so here we go. Let's take a look at it and see where we're going to go with this. So costs from work orders. That's the next thing to figure out. So here are Hassan, welcome in. I was just saying that what we're going to be doing today is extra and above the minimum of what goes in your portfolio submittal. We're going to talk about how to get costs from work orders and using the milling program and then refining it. So I'm going to try to use my milling program and see what I can do to refine it. So you've got the thing available there.
That's what I want to ask you about that.
Yeah. So how do we do that? So let me go over the costs from the work orders, and then I'll do a quick demo here on this, and then we'll see what that looks like for you. Okay. So costs from work orders first. I've got a copy of the work order template that I think I filled it out here. Yeah, I've got some things and I've filled it out. So I'm gonna be working away on this one. So this would be a work order for the block housing.
Okay,
And
do you
I've
want
got,
to record it then?
oh yeah, I'm recording it, but I forgot to turn on my screen.
Good.
There we go. That's gonna be easier to see. I keep doing this. There we go. I do a presentation in one and then I come over to this and go over to another. So it's like, okay, I got it here. There we go. Now I remember. Thank you. So you can see this is a work order that I did. Um, but it's not really in very good order here. So I'm going to pull stock, and that's going to happen from stock. And I'm going to say per BOM. And if I look at my standard times, pull stock is about 5 minutes. So I can say that equals 5 divided by 60.083. Once I pull the stock, I'm going to set up my mill. That'll be in the shop. And I can even put this here if I know what that is. My setup, I usually, let's see what it says for setup. Also 5 minutes. And so that's going to be per the drawing. So that equals 5 divided by 60. Then I'm going to do my mill cuts, and I'm going to do inches per minute, and that's going to happen in the shop. And I have to think now, inches per minute. I can do $3.60 or 3.6 inches per minute. So this is going to equal 3.6 inches per minute times how many inches? So how many 3.6, so I've got 5. I'm going to say it's 30 inches. Okay, and then I have to divide that by 60 to get into hours. I did something wrong there. 3.6 inches per minute. No, it's 30 divided by that. Sorry about that. 30 divided by 3, 6. looks better. 0.13 hours, right? Because if I've got 30 inches divided by 3.6 per minute, tells me how many minutes I get. And then I have to divide all of that by 60 to get that. Okay, so always look at your answers to make sure if they look right. Then I'm going to inspect my part. And I think on this part, I inspect 3 things. And it takes me 1 minute per feature. So that's going to be 3 minutes. It equals 3 divided by 60 to get it into hours. And then I'm going to put it back in stock. Right? And I don't, there's return to stock. Turn to stock. Oh, I didn't fix this. Oh, there it is. Return to stock. That happens in the stock area. And so there's going to be 5 minutes there. Equals 5 minutes divided by 60. So there we go. And then I think I need to be able to saw something. So I need to bring these down here. So, it's not automatic, but that's okay. I have to saw my part. Saw cut. That happens in the shop. It's per the drawing. And I think I've got one saw cut that's going to go through 2 inches of material. Saw cut. So 0.5 minutes per inch. So it's going to take me 1 minute to saw cut it. Equals 1 divided by 60. Not very long. So that's my total hours. That's my setup. Okay? And I'm going to pretend that I've got 10 of these on the work order. Now here's where it gets interesting. I'm going to put another one over here to account for my cost. And I'm just going to bring over whatever is in this part right over here. So I can say that right up here, I'll move it down a little bit. That equals, and I can go over to my template and say that equals that one. That's so cool. And then I can copy that right over. Got a little bit farther to copy it because it's set up a little bit different here, right? So I've got my operation. I can get rid of this one. This is a little bit of playing around. I can get rid of that column. There's my labor hours each. So I can get rid of these. And these I'm going to get rid of also. And now I should be able to copy those down. There they are. Isn't that cool how that works? I love spreadsheets in Excel because now I can take a look at this and I can also say how many of these I'm going to need. This is going to equal how many parts? 10 parts. But how many times do I do this? Okay. Quantity of this operation. How many times do I pull stock? Once. How many times do I cut? I've got 10 of these to do. So it's going to equal whatever is in there. And how many times do I set up my mill? Just once. But how many times do I do this? How many times do I actually mill this thing? It equals whatever's on my work order. And how many times do I have to inspect? I have to go read the drawings, but I'm going to do it 10 times. And how many times do I return it to stock? So this number right here is really, it takes product knowledge. It takes knowledge. It's not automatic. And that's what production control people do. They know about this stuff and they set this template up. So now, how many hours am I going to spend on this particular work order? It equals how many times I'm going to do it times how long I take for each one. And so then my total hours is the sum of all those. So it's going to take me 2.5 hours, 2.3 hours to make all of those parts. That's not too bad, right? That's not too bad. Now, I have to make sure that's right because that seems pretty short compared to what I've been seeing. But we'll just have to look and see. But so it's going to take me 2.31 hours to make 10 items. This is let me put it down here. Total work order hours. And so per part, going to take me 0.23 hours. And what that does is that spreads out the hours for the one-off thing through everything else. So now if I want to do a cost estimate, an accountant would just average all of these up over the last 5, 10, 15 work orders, whatever, and would figure out, they'd take those hours and multiply it by the rate. So we're going to kind of work on that next week. Yeah, it's not very much, is it? It's like, man, not very much at all. Okay. So now, if we find out that we're always wrong, then we have to come back to our standard times and change that. Or figure out that there are other things to do besides mill cutting. But if you were to do this on a CNC, computer numerical control, where it wasn't always the person figuring things out and putting things in there, it would really would make a difference. And remember, this is on full speed. There's times when I have to change that, and so this estimate is maybe not perfect, but it's a good start, right? Maybe I'll have to add a little time in or something. Yeah, but that's how these work orders can be used by other people, accountants, to start looking at how do I calculate costs. Okay, and just as an example, if my shop rate for the manufacturing is maybe $50 an hour, then that part is going to cost me $11 to make. This would be well, that's not terrible. It's not. Now, that's my labor cost. And then there was the cost for the material that we found out last week. So I would add those two parts together. Okay. So you can see it's like, ooh, we want to get those rates down. So first of all, we want to be very efficient as possible in all the things that we do to make that as good as we can. Now look, this is a big chunk right here. my inspection is a big chunk. Production control people go through these things and go, well, if I've got a CNC running, maybe even though it's going to take that much time, my person doesn't have to be doing that, and I can be inspecting a part while that's running. So maybe I can mitigate this somehow by saying, oh, I'm not going to count it. I'm going to say, while you're running the last part, or while you're running this part, go inspect your last part. Because that would really make a big difference. What if that was 0? Look, that made a $2 difference in the price of the part. So this is what manufacturing people do. They go around and figure out, how can I make this faster? How can I make this faster? This one is an obvious one, right? But maybe I can turn up the speed, the maximum speed on my machine, and get that number to be a little bit smaller. Isn't that cool? Now we got data. So this is not needed this week, but you might want to practice it a little bit because we will go over it next week. So, all right. So that is costs from work orders. And there is no, it's like you have to make the work order and then you got to figure this all out. There is no super automatic, easy way to do it. That's not a big, heavy duty, full blown production control program. But this gets you the basics of it. Okay. Any questions on that right off the bat? Okay. So let's go ahead and continue now and look at where did you guys see where I put my, was it in milling assignments that I put mine? No. Where did I put my, I know where I put it. It's in my, sorry, I'm going to get back to it right. I'm messing around here, getting it wrong. I need my milling program sample. So here's a milling program sample. Okay, and I'm going to go ahead and do my best to follow this to do a couple of cuts in Unity. So let me bring this down and put it over here. And I'm going to bring this down and put it over here. And then I have to minimize that. There we go. Okay, so I'm just going to follow these commands. All right, and see if I can do it. And I've sort of memorized what these mean, but my comments help me figure it out also. So I'm going to follow this command by command by command and see what I can do. Okay, so I've got SM1 fast travel on. Fast travel is on. TTMX manual travel. And so I'm going to manual travel to what my estimate for 00 is. And I'm missing one of those lines. That looks pretty close to the center. I'm going to get as good as I can. And right off the bat, I see that this is hard because I'm stuck at 50%. I haven't changed that at all. Yeah, I'm going to call that close to my 00. That was my TTMY. RZ00, the head. I type Z. Oh, I have to get back here and undo that. I'm working in too many places at once. Okay. SC5 says change my cutter to 25. Shoot, I bonked it out. Okay, I'm gonna have to redo this. Okay, let's see if I can do that again. Fast travel is on. See if I can do this right. Over to here. It's about as close to the center as I can get. TTMX, TTMY, RZ0. SC5, change my cutter head. SM2, cut the hole. Set mode 2, that means power on. SM1, fast travel, that was number 7. Number 8, TT and Y to minus 2.424. So I would automatically, but I'm going to have to do it now, minus 2.424. That's probably as close as I'm going to get with this fast travel. So right off the bat, I see that I need to be able to do some slower travel because it's going to be hard for my machine to hit that perfectly. And then it says SM2, start the cutter. TTX minus 2.25. And I'm going so slow because I didn't tell it to go faster. See how slow I'm going? But my command did not tell me to readjust my cut speed. So this is going to take forever. So this is why this part is a little complex. Yes, it is. Okay. But what I'm doing is I just made command kind of abbreviations for what I want to do. And I'm just trying to follow my plan, and I'm doing my cut to see if I can do better. And so I see that my plan is okay, and I'm going to fast travel and I'm going to slow travel and all that kind of stuff. But I forgot about setting my travel speed. So I set what kind of thing I'm doing, and I have to get all the way to minus 2.5. So there's another little problem. I could have easily cut that off earlier. So see how much time I just wasted? I just wasted a lot of time. But I just did that one, TTX minus, now I have to TTX to plus 2.5. Oh my gosh. And I'm going slow. This is going to take forever. And just look at how we're adding to the part cost right now. I'm really adding to the part cost because I'm just wasting time right now. Wasting time, wasting time, wasting time. So this is why after you make your sample program, you go back in and you fix it. I'm going to have to fix my program to give myself some travel speeds. Because I'm just like, oh my gosh, here we go. All right, so you get the idea. All right. So I'm gonna, well, I might as well go all the way just so that you can see what it looks like. Well, this particular CNC controlled program is certainly not going to meet the cost estimate that I was shooting for. So either my cost estimate is way off and my thought processes in my work order, or there's something wrong in my program where it's not as efficient as possible.
So why you didn't put 100% for speed?
Because, well, I should have, but my program didn't tell me to do that. So I turned the machine on, and however it was when it came up is what I got. So that shows you. I mean, I have to go back and fix my program to tell it
Okay.
100%. So I can't do things when I'm practicing like this that it doesn't tell me to do in my program, right? Um, and so what I need to do, and I'll show you in just a sec, I'm almost there. That took a long time. I have to get all the way to 2.25. Here was the other thing, I really ought to be done about now at 2. I should be done at 2. But I'm going all the way to 2.5. Wow. There. Okay. So there we go. So that's done. So what would I do here? You are absolutely right. Why didn't I do that though? Because my commands didn't tell me to do that. When you're programming, you literally have to say every single thing. So after fast travel on, I want to go to my next one that says, hold on, I have to find it now. What are my command lists? I'm going to copy these and put it into my program. I've got it. Okay. Oh, here's set speed. SS1. Set speed fast. Okay, so if I put for fast travel, SS1, 100. And then I'm going to manual travel close. And that should say 100%. And then I'm going to manual travel close to where I want to be. And then I got to slow down. Maybe to 10%. And I'll have to manual travel again. And that should let me line up pretty well. And then I have to set my speed back up again and manual travel in Y. And then I have to slow it down again, manual travel in Y. And then I know I'm going to be cutting, so I have to set my speed back up again. Woo! So all of a sudden that took a lot more. But now I'm ready to zero my head and start my fast travel when I'm cutting will be at the full speed. Okay, so you have to think of things like, and that's why I want experience for you guys on this little milling cutter sample program, because you just do it naturally when you're doing it by hand, right? It's like, oh, well, I'm gonna slow it down and get closer. Well, you had to do that, and so the machine has to do that. Now, you might think that in fast travel, the machine can go whoop and just stop. right there. But that's very hard on a machine. It's hard on the bearings, it's hard on the lead screw, and depending on the mass of the head or the bed or whatever you're moving, that could just really create a lot of forces to try to stop it. So usually there's some sort of slowing it down a little bit. So little bit. And this will take a little bit of time. That may take a quarter of a second to slow down. So that's just kind of cool stuff that you can kind of check out and think about and do. That was the one thing that I thought was really missing in my program. Now I might think right here, after I did my cut in minus X, I might change to fast travel here. And TTX to TTX in the plus direction. But not to 2.5, but to like minus 0.1. And then go in to start my cutter. And then TTX to plus 2.500. So you see how that would at least get me back almost to the middle, and I could start my next cut. And I wouldn't waste quite so much time. Woo! Does that make sense? Cool. So every time what I do, and this, believe it or not, machinists do this. There's a mode on most machine tools called dry run. And it does the program, and you just don't have the block of material there. And so you push dry run, and it does exactly what your thing does, and it lets you imagine all of these things. Well, we don't have one called dry run. Okay. We don't have one called dry run. Although I'll tell you, I think I can have Tristan read your program and do a dry run on. Wouldn't that be cool if Tristan would in Unity now read this and then do it and see what your part is like? Like, oh, that's awesome. And it's really just like the dry run function, but you're actually cutting things away as you see. Okay, there we go. That's what I wanted to go over for lecture. I now have a much better program. And if I were to post this program, somebody could run it for me and check it out. Okay, any other questions left? All right, then that is it. I'm going to turn off